Today we're going to discuss the kinetics of a particle. So we already done with our kinematics, no? We are the rectilinear kinematics, and then we have the curvilinear motion. So in kinematics, we have talked about the motion of the particle, and then considering also its geometry. So there's no forces involved in kinematics. We only talk about its geometry. So purely geometrical agad si kinematics, along with the consideration of the particle's velocity, acceleration, and the position and the time. Now, in kinematics, it is different. No, in kinematics, we are already dealing with the forces. So, in kinematics of a particle, that is based on the Newton's second law of motion, and in these discussions, we'll be talking about the dynamic equilibrium. Okay, let's start. What is a kinematics? Kinematics is a branch of dynamics. So it is a branch of dynamics dealing with the relationship between the change in motion of a body and the forces that causes this change. So in kinematics, no, that is discussion on the geometric property of a moving particle. Now we tackle on the relationship of how forces changes the motion of a body. So that is the kinematics. The basis of kinematics is Newton's second law. So this is the second law of motion of Newton. It states that when an unbalanced force acts on a particle, the particle will accelerate in the direction of the force with a magnitude that is proportional to the force. So, so let's say we have a particle. We know that a particle remains at rest unless acted upon by an external force. So in your statics of rigid bodies, no, the objects are not moving. In the dynamics, the objects or the particle is already in motion. That's why it is in dynamics. Now, sa may Newton's second law, there is an unbalanced force that is acting on a particle. So in the statics, all the forces is balanced and in equilibrium. Here, all the forces is not really balanced. So let's say there is an external force acting on this particle. Let's call the external force as F. We have a force F here. So what do we expect if there is an external force acting on a particle? So ingon niya, sa second law, na kung if there is unbalanced force acting on a particle, the particle will what? The particle will be in motion. It will move or accelerate in the direction of the force. So this is our force, and then it has a line of action. So in line of action is this one. And then it states that if the force is applied on a particle, this particle will move along the line of action of our force. So it will accelerate in that direction with a magnitude that is proportional to the force. So the magnitude of the force is proportional to the force. Okay, so mula na siya yung concept. So you have a particle, and then nag-apply kag force, and then pag-apply mo sa force, the particle will move. So that is the concept of the second law. And aside from that, ingon niya nga that the force daw kuno, or force F, is directly proportional to the acceleration. So if we put an equal sign, if we equate that, we have a constant of proportionality, which is K. Now, to solve this K, or the constant of proportionality for the force and acceleration, so na-experiment sila, no? And then they found out that this constant of proportionality K is no other than the mass of the particle. So the mass of the particle is a positive scalar. That is always positive, si mass. And what else? What is the other property of the mass? The mass is always constant, regardless of the force applied or regardless of the acceleration sa ato ang particle. So, mo na siya. And since the mass is constant, the mass provides a quantitative measure of the resistance of the particles to change in its velocity. So, si mass daw kuno is a quantitative measure of the object, of the resistance of the object to change. So, we call this the inertia. So, ano siya si inertia, no? So, dali lang na siya imagine nun. The more nga bugat ang butang, the more siya lisod i-change nimo iyang velocity. So, ano na siya? The greater the mass, the greater the inertia. When more than one force acts on a particle, so in a previous slide, isa naman to ka-force no atong gibutang, we have a one unbalanced force. But now, niya kung if we have more than one force acting on a particle, so what are we are gonna do next? We'll try to get the resultant force. The resultant force is determined by a vector summation of all the forces. For this more general case, the equation of motion may be written as the summation of all vector force is equal to mass times the vector acceleration. So kung there are more than one forces acting on a particle, now we have a vector force. If you notice, no, that is written in bold letter F, it denotes a vector force. A bold letter A denotes a vector acceleration. So ingon niya nga if more than one force acts on particle, you just get the resultant force. The resultant force, vector force, is just the so we have a particle here, you know, that is acted upon by two vector forces F1 and F2. So from this example, the resultant force is just equal to the summation of the vector force 1 plus vector force 2. This is the resultant. And then how about the direction? Asa man iya ang direction ani? The direction of the particle will be like this. By parallelogram method, we know that this is our resultant force. This is a vector force F. So the direction of the resultant force will be the direction of the particle. This is true for a particle nga gi-applyan of several forces. That's why we have a force 1 here that is going downward and a force 2 going upward. But the resultant force is along this direction. Therefore, our acceleration vector A is towards this direction or towards the left in this example. Since this is a vector quantity, we have the summation of forces. This is the vector summation. Then, therefore, that is also equal to the vector summation of its rectangular components. The summation along its x, the vector summation of forces along x, plus the summation of vector forces along y, plus the vector summation of forces along z. We call this our rectangular components. This is the vector quantity. And then this is also equal to the mass times the acceleration of object along x, the vector acceleration, and etc. Now we can rewrite this into resultant form. The summation of the forces along x is just equal to the mass times the acceleration along x. The summation of forces along that is being applied to the particle is equal to the mass times the acceleration of the particle along y, and the summation of forces along z is just equal to the mass times the acceleration of the object along z. So this is what we call our equation of motion. Actually, mo ni nga formulas ang inyong generally are usually ginagamit during your statics of rigid bodies. But since in static of rigid bodies, the body is in equilibrium and at the same time that is static, the acceleration is zero. That's why, direction na siya nga, the summation of forces along x is equal to zero, the summation of forces along y is equal to zero, summation of forces along z is equal to zero. So ano basin mag-wonder mo why we have this summation of forces along x, f, y, and z. Because we know here we already consider no, the three-dimensional motion of of our particle. So we call this our rectangular components. So let's say we have a coordinates. We have the x-axis. We also have our y-axis here, and then we also have our z-axis on this side. So let's say we have a particle on this side, and then a force F, vector force F is being applied here. The direction of our vector force F or the unbalanced force F is equal to the direction of the acceleration. Since vector components or vector quantities can be written into components, we can get the component of this vector force along x, along y, or along z. Same is true for the acceleration. We can get component of the acceleration along x, y, and z, and same also with its velocity and the position. So, mo na din siya. Kung position sa istoryahan, that is x na din na, x1, x2, etc. If along y, then we have the y1, y2, and along z, we have the z sub 1 and z sub 2. Okay, so that is the concept of the kinetics of a particle. The particle is being acted upon by an unbalanced force, and then if there are more than one force acting on a particle, the particle will move along the direction of its resultant, like this one. It will accelerate to the direction or to the line of action of its resultant force. Now, if we have a vector summation here that is equal to the mass times the vector acceleration A. See, mass is always constant, that is a positive scalar. Acceleration and the forces are vector quantities. But these vector quantities can be resolved into uh, the rectangular components, that is the summation of forces along x, forces along y, and the forces along z. And this principle, the principle of the kinetics of a particle, is based on the Newton's second law of motion, and we will come up with the equation of motion. So, muna siya ang si kinetics of a